Hi guys. Right, so we're returning to logs and looking at how I might solve these equations using logs. And it's all just involving those power laws that we've got so far. So the first thing I recognise about this one is I've got my x that I want to find in the power, which causes me some problems. So if I take a log to both sides, that has the effect of enabling me to bring this power down as a multiplier at the beginning. That's one of the key laws of logs that we've done. So I've got 4x minus 1 times log 5 is equal to log 61. So this is times in here. In order to do that times, I'm going to divide both sides by log 5. So 4x minus 1 equals log 61 divided by log 5. Now remember, before I said it doesn't matter what log you use. Old calculators would have log to the base 10 and log to the base e. To make this easier, I might choose log to the base 5. So I'm going to go log to the base 5 of 61 divided by log to the base 5 of 5. What power of 5 is 5? So that would be 1. So we've got 2.554, and I'm going to store that in memory A, so I'll press STO and then an A, where the A is, and that's now firmly linked in memory A. So I can now add 1 to both sides. So 4x is equal to 3.554, and then divide both sides by 4. Give me what x equals. So I'm going to do my memory A, so I press alpha A plus 1 equals my 3.554, and then I'm going to divide by 4, and that equals 0.888557. So I'm going to go from 0.889 to 3 significant figures. So I think it would be prudent at the moment to check that back. So I'm going to store this one in memory B. So I've got my pink letter B above there, which I'll be able to get back using the alpha button. So I'm going to press 5 to the power of 4 alpha B minus 1 equals 61. Phew. So that's got us through that one. And remember that it wouldn't have made any difference at all what base I would have used. If I'd have used log to the base 10 on both of these, I would have got 2.554. If I'd have used log to the base e, I would have got 2.554. It doesn't matter what base you use. Just interesting, log to the base 5 of 5 is 1. In other words, what power of 5 gives me 5, and that's 1. So that may have made a step fewer for us to do, but we don't really need to worry about that. Right, so moving on to this second question. Jumping out at me on this question is a quadratic. Now I just want to address this for the moment. That is the same as saying 5 to the x squared. So remember, when you times a power, so when you take a power of a power, the powers times together. This isn't 5 to the x squared, this is 5 to the 2x, which is what we've got there, because the 2 and the x times together. Power of a power multiplied. Minus 12, 5 to the x, plus 20 equals 0. So that's the first thing we need to recognise. Now, you can see the quadratic, but sometimes there's a bit much going on there for you to realise that it, or for you to be comfortable with it being a quadratic. So what I'm going to do is I'm going to do a little substitution, say y equals 5 to the x. So I've got y squared minus 12y plus 20 equals 0. So now I can say that I've got y minus 10 and y minus 2. So y is equal to 10 or 2. So breaking that back and undoing the substitution, I can say that 5 to the x is equal to 10, and I can say here that 5 to the x is equal to 2. Now it might be a good idea to use log to the base 5 here, because that will make things quicker. So if I said log to the base 5 of 10 would equal x in this case, and log to the base 5 of 2 is equal to x in that case. So remember what this says is what power of 5 is 10. What power of 5 is 10, and that's what gives us the answer x. What power of 5 is 2, and that gives us the answer x there. So going to my calculator again, I've got log to the base 5 of 10, and that comes to 1.43. 3 to 3 significant figures, and you'd expect that because 5 to the 1 is 5 and 5 to the 2 is 25, so you'd expect 10 to come in between 5 and 25, so in between 1 and 2 in the power. And just scrolling back, I'm going to change my 10 to a 2, and that gives me x equals 0.431. And again, 5 to the 0 is 1, 5 to the 1 is 2, so you would expect your answer to come somewhere in between those two. Okay, hopefully you've understood that nicely. Just applying the laws we've done. I think this is a crucial point on the quadratic, and by all means use a little substitution just to make it easier for you.